Hello, everyone. Welcome to today's webcast on Uniting Electrical and Mechanical Engineering. I'm the moderator, Krista Prokos. Before we get started, I want to let you know that you can submit questions for today's presenter by typing them into the Q&A panel at any time. We'll collect them and address them at the end of the presentation. Now I'd like to introduce our presenter. We're happy to have with us today Mark Talbott. Mark is an electrical specialist at Fisher Unitech. Mark, take it away.
Thanks, Krista. So just a few things about me. I have a master's degree from the University of Akron. I've also been in the manufacturing space for about 8 years in the past, and that came with SolidWorks experience as well. And that was in motor design and the elevator industry. I've got a host of certifications, specifically in the electrical products, PCB. I also have some mechanical certifications as well. So today our agenda, we're going to basically go through what's so great about a collaborative platform. Why do we need to start from a design standpoint from a collaborative platform? And then we'll go into an overview of electrical schematic professional and electrical 3D as well. And that'll be followed by a demonstration that will connect everything together, and then we'll go into your guys' questions and answers. So what collaboration is available with this electrical setup? Well, there's two forms of collaboration, and that's multi-user and multi-software. And so what I mean by multi-user is that you can have several licenses of SolidWorks Electrical Schematic, and these can all log in at the same time. They can edit, work on, and view the same projects simultaneously on the schematic side. And this is done with the professional software. So by multi-software, what I mean is that with Electrical 3D, you can take that schematic information and utilize it in your mechanical CAD package in SolidWorks. And this comes with simultaneous use with the schematic side as well as chat, and you're able to organize that information with the schematic users. And being able to go across platform from SolidWorks Electrical Schematic to your mechanical environment, this really allows you to access those tools that are available within SolidWorks, things like premium features such as flow, simulation, conduit routing, things like that. So why start with collaboration? So I'm starting here with series versus parallel workflow. What's very common in the industry is having kind of a serial workflow where it goes from one department to another, and maybe you go from your electrical to your mechanical, and then the mechanical side of things, they just try to get it off their desk as fast as possible, and it goes back, and then they kind of wait, twiddle their thumbs, work on other projects. So it's a very disjointed process, disjointed thinking. Whereas with parallel workflow, it allows both teams to work together, to work simultaneously, and it allows them to stay immersed in a project without becoming disjointed and distracted with other projects. Ultimately, this allows for better development times, cycle times, time to market, project cost, and it also allows for better communication. So having a collaborative platform, it improves inter and intra-departmental communication, communication among your direct peers, and communication across departments. This also grants you improved resource and response control. So if you have projects that are sort of emergency projects or that are falling behind in deadline, with collaboration, you're able to allocate more resources toward that, and you're able to control and flow those resources in and out of projects more seamlessly. And it allows people to work on those projects in a way that's more efficient instead of just being, the on the sidelines documenter or whatever. They can actually get into the project and work at full capacity. And ultimately, having a collaborative platform, it helps you stay relevant in today's market. These tools are available for people to use. Companies are gearing towards communication and collaboration. So there's value in being on the front end of that movement to remain successful and competitive. So what is SolidWorks Electrical Schematic? What tools does it offer? What does it do for you? So first off, it offers fast schematic creation with error control. This includes rapid searching for symbols, components. There's automated features such as the labeling of device tags, wire numbers, things like reporting and error checking. And these can all be customized to how they're displayed per the user or the company in question. There's also industry templates and data automation available within Schematic. These templates can be, again, customized by you, designed by you, and you can also create file sets or reusable circuits called macros, or even on the project level, reusable projects. And these can really be used as time-saving techniques. Things like Excel automation can be used as well to save time, and these are essentially templates, Excel file templates that with small tweaks can actually produce an entire project for you just with the click of a button. There are library tools, managements for components, symbols, manufacturing parts, wire cable management, and these are done on the project or the book level. So with rapid documentation, rapid changes, professional documentation, this allows for out-of-the-box processes and reports that can be edited, that can be run when changes are needed, and this will essentially allow for project cohesiveness and it eliminates errors, allowing for better integrity to your project. And of course, the quality outputs that are available for your standard projects that your customers or your suppliers need. And this really allows electrical schematic to, as a design package, to fit any of your needs. I do want to make a note at this point that SOLIDWORKS electrical schematic is completely standalone. It is not required to have SOLIDWORKS or any other mechanical ecosystem, but for the sake of collaboration and uniting your electrical and mechanical teams, we'll move forward with this discussion to electrical 3D. So what is electrical 3D? Well, first of all, it's the component that's needed to connect your schematic software to your mechanical design environment, to SOLIDWORKS. So it's linked through the bill of material and library. With SOLIDWORKS Electrical 3D, the project documents can be reviewed within SOLIDWORKS Mechanical. So you can see the whole project that the schematic user has developed. You can use that as a reference tool. And there's also component information with linked 3D footprints that are available to insert. And that's all organized on the schematic side. So everything's linked, and this allows for automated assembly creation. Also available is automated routing with property referencing. So when you have a panel and you've inserted your components that are in your component tree, the software is able to reference those origin destinations and things like your wire size or your wire diameter, your colors, minimum bend radius, things like that. And that allows you to get a realistic looking panel. It allows you to really understand the 3D footprint and layout and clearance issues, or even the aesthetic of your project. There's also realistic physical information that can be automated for reporting. So not only do you get this great render of your project, but you can have things like duct fill or even wire length reported back. And this information can really be used to optimize your control over the manufacturing process. So with the way the industry is moving today, with outsourcing or things like that, being able to maybe speed up your manufacturing process by reporting wire length, that's a tool that would be available with the SOLIDWORKS 3D add-on. So next I'd like to go through a brief demonstration. And so what you're seeing here is electrical 2D schematic. And I'm just showing you kind of how you organize your files, your multi-line, your single-line documents. You can add in reference documents, PDFs, your solid files, and assemblies can all be contained in electrical schematic. And here I've opened a single-line diagram, and I'm going to copy this motor over and add it. And you'll see that it automatically sequences to motor M5. So this is SQL database. And then I'm going to draw a cable up and connect it to my terminal blocks. And then I'll connect this on through to the rest of the circuit. So single line schematic, it's not required in your design. It's kind of used as an overview tool. But next I want to show you that these lines are not simply just lines, they actually have background information. I can add a cable or a core reservation, which I'm doing now, and actually connect up and add terminals to connect up both sides of that cable. It can be connected up in any order, and then you can even reference those connections and what order they're in. And now my cable is labeled. So again, these lines afford background information that you can use for the rest of your project. Which brings us to our multi-line schematic. Here I want to show you some macro tools. You can create macros, which is collections of circuits, and simply drag them into your project. So if you have a common collection of circuits, that's available for all users on the network. And then you can simply associate those symbols to your project. And here's the motor that we've added. And then I'll go ahead and associate my other symbols as well. And you'll see that you get a real-time preview of where that information is being referenced currently. So if everything is associated up, I'm going to go ahead and add in some terminals. And I can add in multiple terminals at a time, just simply drawing a line across, and I'll associate them with the terminals I've added on my single line diagram. Next, I'll go ahead and show off some shortcuts for inserting symbols. So you can organize the way that your symbols are displayed in groups. I can create my own. I can also just find groups within my symbol libraries by typing in the names. Or I can use the standard library, standard way of inserting symbols, and you'll see that I can organize these symbols by classification. You can view them in list mode, you can filter, and again, that SQL database, it's SQL in the background, so there's quick searching is available. Making connections, it's as simple as copying and pasting. You can select a symbol and select Go To, and that'll show you anywhere where that symbol is being referenced, and you can verify those connections as well. And here you'll see a PLC with some circuits attached to the outputs. You can actually automate that process and select which collection of circuits are to be allocated for specific outputs. So it pastes your whole PLC in one shot. Here you have a 2D drawing of your panel, and then we'll go into reporting. So out of the box, you have a slew of reports that are available. These are all editable. You can get them to display however you want. I'll go ahead and generate a few reports, and we can view those. So my bills of materials, I have them grouped by manufacturer. You can have them just grouped in order. I have some cable reporting here. And from this point, we'll go ahead and move to SOLIDWORKS 3D so you can see in the mechanical package how this information is referenced. So here we are on SOLIDWORKS with the 3D add-in. I've opened the project, and you can see that I can reference the same information. I can view this information. I can even organize folders as needed. And we'll go ahead and open the assembly associated with this project. So this panel before you is kind of where we'll be going. It's connected up to a motor, and we'll change our configuration to the enclosure that we worked on in the back. Here's the motor that we've added. The mechanical user already added it, and now that it's documented on the schematic side, he can associate that to the project so that those components will be linked. Here's the panel that I've added, and I can see all the components that have not been inserted yet, so I can select those and insert those in any order as needed. And you simply select the spacing, and those will populate for you. And these are based on smart components with smart mates added in. Same thing with the terminal strips. I'll do 0 spacing and add those in. And then I can align those components as needed to get the desired spacing. And that just adds width mates in between my components. And you can drag these into place or finish mating them as needed. At this point, we're ready to route up our panel. So first I'll insert this light. And with any component in SOLIDWORKS, I can add in smart features. And we'll have a hole that is automatically cut for this light to be put into the panel. And now with routing, I'll go ahead and route with splines. And this references the schematic information, your from to origin destination. It gets your color information, your diameters, and really gives a realistic profile, realistic length. And again, it can provide things like duct fill, and I can use that length for reporting. So I'll go ahead and route my cables. And in a similar process, the cables are routed to connect my motor to my panel. And then we'll go ahead and update our bill of material properties. And once that's done, I can review the reports in the schematic and see that my lengths have been updated as well. So that completes our demonstration. So in summary for this webcast, we've talked about designing with a collaborative platform, those benefits that you get in industry. We've talked about an overview of SOLIDWORKS Electrical Schematic Professional, as well as SOLIDWORKS Electrical 3D, and how those fit together into the mechanical space. And then we went through a brief demonstration of maybe a workflow that would connect that design all the way through. So this concludes the presentation portion of our webcast, and I want to thank you for your attendance.